In 1947, a newly independent India faced a monumental terrestrial crisis. The primary directive for the nation was figuring out how to feed, house, and sustain a massive population trapped in deep agrarian poverty. Yet, amid this struggle for basic survival, physicists Homi Bhabha and Vikram Sarabhai convinced the government to establish a National Space Research Committee in 1962. The operation started in a fishing hamlet called Tumba. Scientists set up their workspaces in a local church and transported the nose cones of early atmospheric sounding rockets to the launch pad on the back of a bicycle. Critics naturally questioned why a developing nation was spending scarce capital on aerospace engineering. Sarabhai's thesis was exact. India had no interest in competing with superpowers for lunar dominance. Instead, they would apply advanced rocket technology to terrestrial problems, deploying satellites for weather forecasting, for resource mapping, and agricultural planning. The organization was forged from the necessity of earthly survival. By the late 1970s, the agency needed to transition from launching small atmospheric probes to building orbital launch vehicles capable of carrying heavy payloads into low Earth orbit. That ambition collided with reality in 1979. The maiden flight of the Satellite Launch Vehicle, or SLV-3, failed shortly after liftoff, crashing into the Bay of Bengal and devastating the engineering team. The project director, APJ Abdul Kalam, absorbed the responsibility for the crash. He aggressively reorganized the engineering units, and exactly 1 year later, the SLV-3 successfully placed the Rohini satellite into orbit. The collapse of the first SLV-3 and the subsequent victory of the second defined ISRO's engineering philosophy: resilient, ruthless iteration. That resilience was tested by external forces during the 1999 Kargil War. As Indian troops fought in high-altitude mountainous terrain, the United States denied India access to crucial global positioning system data. The exclusion in Kargil redefined India's priorities. To secure technological sovereignty, the government moved to build a domestic navigation infrastructure, the Navik satellite constellation. This map illustrates another severe blockade. In the 1990s, India attempted to acquire highly complex cryogenic upper-stage engine technology from Russia. The United States intervened and severed the transfer agreement. Forced into a corner, ISRO committed to mastering cryogenic fluid dynamics entirely in-house. It took them 2 decades of relentless testing to successfully design, build, and fly their own cryogenic engines. With independent heavy lift capabilities secured, Prime Minister Atal Bihari Vajpayee declared in 2003 the newly empowered agency would pivot toward deep space and planetary exploration. 10 years later, the Mars orbiter mission, known as Mangalyaan, launched toward the Red Planet. The entire mission cost $74 million, a budget lower than what Hollywood spends to produce a single science fiction film. Western media openly mocked the ambition. The New York Times published a cartoon depicting an Indian farmer with a cow knocking on the door of the elite space club. Mangalyaan answered that skepticism by making India the first nation in history to reach Mars orbit on its very first attempt. ISRO had successfully weaponized its own frugality. They turned crippling budget constraints and decades of international embargoes into their greatest competitive advantage. The agency's lunar ambitions yielded similar high-yield science. In 2008, the Chandrayaan-1 orbiter dropped a probe that directly detected water molecules on the lunar surface. However, the follow-up mission in 2019 ended in heartbreak. The Chandrayaan-2 Vikram lander deviated from its trajectory and lost all communication with mission control mere moments before touchdown. In August 2023, ISRO returned. Chandrayaan-3 targeted the lunar South Pole, a notoriously rugged, shadowed region littered with hazardous craters. The lander executed a flawless touchdown. India became the 4th nation to land on the Moon, and the first to conquer the southern polar region. The agency's autonomous trajectory is now expanding to human spaceflight. The upcoming Gaganyaan program aims to put Indian astronauts into orbit, setting the foundation for the domestic Bharatiya Antariksh Station. A program that once transported rocket components on a bicycle now manufactures massive indigenous heavy-lift launch vehicles capable of deep space deployment. By mastering the mechanics of space, ISRO secured technological independence for a nation of over 1 billion people.